This is Hussein Ahmed. My ID is 221154694. Now I am going to discuss about the exploring the data link layers and the network layers. Here I put an overview of OSI model. OSI model basically calls Open System Interconnections models. It basically visualize the layered structures of network and it facilitates node-to-node data transfers within the same network that I mentioned the names of data link layers. It also facilitates the network layer. It manages routing between devices on different networks. Here I mentioned about the data link layer introductions. Data link layer introduction basically is play primary roles, some key functions, and some protocols. In primary role, it's connect node to node data transfer within the same network. There's I mentioned about in my OSA model explanations. And its key function is it's detect eroute and it's what for frame synchronizations and for MAC address. It uses protocols for Ethernet and Wi-Fi that are widely used. Here I mentioned data link layer that is parts of OSI models. OSI models have 7 parts or 7 steps, you can say. There's it are application model, application layer, presentation layer, and session layer, and the transport layer, network layer, and the last one is data link layer and physical layer. Each function basically sends blocks of data frames between physical device, and it also regulates access to the physical media. It has some key challenges also. Those are it's how to delineate the frames and how to detect errors. It's how to perform the make or we can say that media access control, how to recover from and avoid collisions. All the answers of these questions we see for to my next explanations. Let's go. Ethernet technology. What is Ethernet technology? Ethernet is widely used in a protocol that's for is used in local area networks. In short version, it calls LANs. And its frame structure is source and destinations of MAC address. It it basically transfer its data for two frame systems. For transferring data or packet from one device to another device, it detects the MAC access or you can say the MAC address of two devices, source device and the destination device. It detects a device for transfer data or packet from one device to another device. It identifies the MAC address of this device and it transfer packets by frame-wise. That that here I mentioned in short form, that is FCM. LAN application typically used in home or office networks. That is widely used in LAN applications. Data communication process in the Ethernet. It basically explains the process of Ethernet that's using this Ethernet data can communicate from one device to another device. Process in Ethernet. Here I mentioned 3 main topics that are used for data communication. First one is device identification, second one is transmission initiation, and the third one is collision detections. In device identifications, the device basically works to identify the MAC address of one device and the device that they can transfer the data. And transmission initiation is basically at first listen for the network inactivity before initiation data transmission. That means before transmitting a packet from one device to another device, the sender device at first listen clearly that the network is busy or is okay for collect the packets from sender device. For this, it's at first gives a message or send a message to the network for check it. I put a huge explain to my next slide. In the time we can know more details. The third one is collision detections. Collision detection basically words is there is any collisions or there is any simultaneous transmissions, and it by using this it ensures the data integrity. Now we see the advantage and disadvantage of Ethernet. Ethernet has some advantage and also some disadvantages. Ethernet is cost-effective implementations, backward compatibility with other standards, and it's also transfer the high-speed data, and it has capability to transfer the high-speed data. It's also reliable and stable connections. But the disadvantage is its limited mobility due to wired connections. Since for connected Ethernet, we need wire, so there is a limited connections or the limited limitations that we connect these networks. Distance is a matter of for these connections. We can only connect this network from for a large for a small network, or we cannot use it for large network, because here a topic is mentioned that is due to its wire connections, we have a limited mobility. Here we see the switching process for forwarding and the filtering process also. Here I divide the process in three portions, that is process, descriptions, and benefits. In forward process, it basically sends frames to intended receptions using MAC address, and its benefits is it efficient for data delivery. And the filtering process is basically block the irrelevant frames from reaching unintended destinations, and it also reduce the network congestions. Link layer switching. Link layer switching feature basically what's in the link layer switching features. Link layer switching features. Here I mentioned three topics, that is high throughput, VLAN support, and quality of service. High throughput is basically handles multiple connections simultaneously with the full duplex communications for optimal performance. Full duplex means it sends data at a time to the its destination device, and in the times also the destination device can send a packet or data to this sender device. That means at a time two devices can communications with them. The second one is VLAN support. VLAN support basically enables network segmentation for improved traffic control and enhances security. Its quality of services prioritizes the critical traffic type like a video and voice for seamless communications. It has some challenges also. That is, it's broadcast traffic overload. That is, and the solution for this problem is using VLANs. And its network performance basically switches, and it has some scalability issues also. Network layer introductions. Network layer introductions basically works in routings, protocols, and packet structures. Routed means it sends direct packets between different networks, and it has some protocols like IPv4, IPv6, ICMP are the key. Here IPv4 is 4 octet, that means it has total 32 bits, and it packet structures is it uses headers process, IPs process, and payload compose for data packets. IPv4 versus IPv6 addressing. What is IPv4 address and what is IPv6 addressing? That's I explained in my previous slide, that is IPv4 is 32 bits limited, and it has limited space, and it also the net reliance. IPv6 basically 128 bit, and it has vast space, and it's some better security compared to the IPv4. Here I give an example of IPv6 address. Public versus private IP. That means a IP that can use some of you that can use people that in a local area or in a local area, but in private IP address we cannot, or some people cannot use this IP. Only can use this private IP in these people. Those are give access to these networks. Suppose in public IP, global Unix assigned by ICFS, but in private IPs used in local networks and is not routable. In public network or public IPs, it has specific branch for private and public IP. Both have the ranges, specific ranges. An example of ranges, the predefined ranges for public and the private uses. Public versus private IP basically public versus private IP use cases. The public IP use cases basically the servers and the cloud service, and the private IP is basically the home networks and the IoT device. Why do we need the private IPs? There's a common questions for our why we need the private IPs. Private IP basically needs the IP conservations for network security and for filter the multiple device connections. IP conservation means it preserves the limited pool of public IPs, and network security means it marks internal IPs from external access. That means only those people can access to this network that devices are give access from the author of this network. And multiple device connection means it is also many devices to share a single public IP. Now we are see the introductions of NAT. NAT means network address translations. Network address translations basically works by following three main topics that are IP address translations, security enhancement, and the IP conservations. What is IP address translations? It enables the device on a private network to share a single public IP, and it's also mentioned the security enhancement that hides the internal network structures and IP address. That means in transmitting data from one device to another device, the connected device only can show the names of this network, but they cannot show the internal network structure. That means is it have to play but it cannot show the internal structures of this IP address. IP conservation means it optimizes the use of public IP address. And I mentioned the network address translations, ties, purpose, and its advantage. Its purpose is basically we use network address translations for multiple device share in a single IP. That means a IP that uses multiple device. That means at a time 4 or 5 devices connected to a single network. And the types of network address translation is static, dynamic, and put address translations also. The advantage of network address translation is it conserves IPs and enhance the securities. Sorry. How network address translation is worse. Let's go here see the process of this network transmissions. At first, it's make a request, then it's translation the address, then it makes the communication between the device. And the third one is the response of routing. At first, it um, request the device, that device send request with the private IP. Using private IP, the device at first send request to receiver IPs. After that, router translates the private to public IP. And the third is internet communication. That means request reaches the internet using public IP. Um, the request that sent from private IP is reaches the public IP internet. And the fourth, when the routing is response is direct back to the device. Here I mentioned some type of network address transmission that are static NAT, dynamic NAT, and the third one is PAT, that means process address transmissions. What is static net that, or static network address transmissions? That means static means one-to-one mapping, and dynamic means one-to-many, or static mean one-to-one, and the dynamic mean one-to-many or many-to-many. Static net means one-to-one mapping of private and public IPs, but the dynamic net is maps private IPs to a pool of public IPs. And the last one is uses unique port numbers for multiple private IPs shared in a single public IP. It is some advantage and disadvantage also, that is IP conservations enhance the security and is also the cost efficiency. IP conservation is basically reduces the need for multiple public IPs, and it hides the internal Ethernet network structures. And the disadvantage of this is it's a challenges for protocol that can interface with specific protocols, and the latency is increased for extra processing time for address translations. And the external access limitations, devices behind NAT and can be difficult to reach. Here we see the tunnel. In tunneling in computer networks. What is tunneling in computer networks? Here I put a picture to my left side that's that show a tunnel, and some of packets are go to the or go to the tunnel bar and reach out to the end of this tunnel. That means if we can imagine that this is the sender and this is the receiver. By using tunnel, this called is tunnel. By using tunnel, we can send packet from sender to receiver. But why we use tunnel? We can see the packets without using tunnels. So here a question also makes, that is why we use tunnels. Let's go. We see the answers of these questions. Tunnel basically a fundamental concept of computer network that allows data to traverse incommunicable networks by encapsulations one protocol data packet within another protocol's packets. This process ensures seamless communication between different networks. Another concepts of tunnels that's basically define that add a header with the tunnel or the data that I want to transfer from one device to another device or one network to another network, that from IPv4 to IPv6. For example, we can imagine a network that are we can imagine a network that are IPv4, sorry, IPv4, and also the receiver is IPv4, but in the meantime there is occurs a collisions, collisions in different network, that is IPv6. In the time we cannot send data from IPv4 to IPv4 network. There are in same networks, but here a different network is occurs or attend. For this reason, we here use a header transmissions all for solve these problems. For this reason, we basically add a header in this network, and then we can easily send data from IPv4 to IPv4. Now we are see the next slides, that is challenges of header translations. It's some challenges also, that is overhead in processing and the potentials for translations errors. Header translation requires additional process steps which can introduce overhead and potential slow for network performance. And it has some potentials for translation errors, that are basically errors during the header translations can lead to data corruptions or loss, compressing the integrity of translation informations. Here I put the differences of some more compatibility between the 802.3 versus wireless network. That is, Ethernet has one started collision domain, and 802.11 uses CSMA or CA node. CA node, that means CSMA versus CD. Collision avoidance rather than the collision detections. Um, now we are see the explanations of this 802.3, that means hidden terminal problem. What is hidden terminal problem? Hidden terminal problem basically the produce on the same network that cannot always hear each other's. That means at a time when it's want to hear one each other, in the time a collision makes. Here I put this, that is, here we can see the three layer, that is sender and that is receiver. In the mid times, here a collisions occurs when the sender and receiver in at a time can want to hear. That means when two devices A and C both are say or send data at a time, in the time the A device or sender device cannot also hear the receiver device data, and the receiver device also cannot see or hear the data of the sender aim. That means here in the midpoints a collisions occurs. That's the problems of the hidden terminal. Now we are seeing the next slides. In the next slides, here I give some animations or use some animation for this time shortens. Here I avoid this and go to the final. Let's say the carrier sense detects and the by busy channels. Carrier sense can erroneously reduce the utilization. Utilization means urbanizations. Reachability in wireless. Here we see the process of the MACA or multiple access with collision avoidance. How the device avoid the collisions between two devices. Here I make a visual. Here I put a visual representation of this. Here we can see the okay. Here you can see the a process that sender and receiver can communicate with each other. That means if we call that is A or whose device and the receiver is B. So mm, sorry for the time given. Here now we are see visual representations of MAC, that means multiple access with the collision avoidance. It's developed in 1990. Now let's see how it works. At first, we can imagine A, that is host and sender range, and the B is host and receiver range. When from sender A to receiver B, that they need to make communications from sender A to sender B. In the time, sender A makes a request to receiver, that means receiver network. That's here I here we see uh, here we see the RTS. RTS means request to send. Sender give sender through a request to receiver for no. Is it the network? Is it the network busy or is it okay for collect the data from the sender device? And after receive the message from the sender, that means RTS, in the time receiver device um, also gives a return message to sender device. There's are here called to clear to send. In short versions, we can say it CTS. That means clear to send. When the receiver device return the message for uh, sender device, that is CTS, in the time sender device can understood that the network layer, that the network is okay for receive the data. In the time the sender device show the data for receiver device, and when the receiver device the collect this data from this networks that's shown by the sender, it's give a return message for senders, that is ACK. ACK means it's receive the data properly. And when the sender device receive the ACK message in the term, it can understand that those messages he sent for receiver device is he receives successfully in the time. That's here I mentioned here I gives a notation that we can see ACK means successful transmissions. That's all from my questions. Thank you.